All right, so let's get started with the talk. My name's Ben. I've been around Athens for a while, and I've been programming for a few years now. Most of the talks that I've given have been about Haskell and functional programming and stuff like that, but this one is not explicitly about that. Today, I just wanted to talk about like various techniques that I've taken in like doing kind of large-scale, finicky refactors of programs that I've worked on. So yeah. I like to consider myself a code murderer. I really like deleting code. It's one of the greatest joys in life. So these are a couple of my pull requests from my last job. You know, deleting 10,000 lines of code is just great. It brings me joy. Yeah, I think it's one of those things that we really like doing as programmers. So I'm going to talk about like how a couple of techniques and like how I've done this, and also not just deleting code, but changing code from one format to another. And the first thing that we should probably talk about is like when you should consider doing something like this. And my rule of thumb is that you should always refactor your code when it becomes harder to modify than it is to rewrite. So if you find yourself like going between two different formats of things, and one of those formats is like really painful to use, it might be time for a refactor. Or if you just find that some pattern that you are using just doesn't fit as you've grown, it might be time to refactor. And I'm going to talk about 6 different ways, 6 different levels of ways that you can kind of approach this problem of like making these sort of rote changes to make your life easier. All right, so the first thing is something that we've probably all done, just how to replace a string in a single file, every occurrence of that string. So I use Vim as a text editor. This is how you do it in Vim. So % means in the current file, S means start a string replacement. The first thing is blah. So if I have a whole bunch of occurrences of blah, I want to replace them with zing. /gc means globally on each line. So take every occurrence of that thing, in this case blah, and C means check with me before you do it. So it'll prompt you to say like yes or no to changing each occurrence of that thing. So for example, if I have this JavaScript code up here, I've got a function called thing, and then I've got another function called double twice that calls thing twice. Thing is a really terrible name for this function, and I want to replace it with double. I'd call %s/thing double gc, press y a bunch of times, and it would turn it into this code. Is that clear to everybody? Familiar? Cool. So that's one way of doing things. I actually find this comes up a whole lot just in general development, making sure that your things are named appropriately. This makes that really easy. And yeah, it definitely has cut off hours of my work from when I was using like a crappy text editor and not knowing about this kind of thing. All right. So with that in our tool bag, let's go on to the next thing, project-wide string replacement. The reason I chose this GIF was because the first thing was like guitar strings, and I thought this was funny. So suppose that you want to do the same sort of thing, but you want to do it over an entire directory of code. So assuming that you have one directory where you keep all of your code, and you want to change one string to another, this is how you can do it. So this is just like a sed command. Basically, it says find all of the files in the current directory, and then execute sed with this command over every file in that directory. So if in my current directory I'm trying to change kablam to alakazam in every single file, this command will do it. This is pretty easy to find if you just do like a search on Stack Overflow, but it actually comes in handy quite a bit Again, if you're trying to change like the name of, for example, if you have like a really poorly named function and you want to change the name of that function, in your whole entire project, you can use this to do that. Relatively unsafely, but that's what Git's for. So. And so one example of where this might be appropriate is React. Does anybody use React here? No? Nobody uses React? That's really surprising. Maybe I live in my own little bubble where everybody uses React. Well, okay, so if you use JavaScript, you have these import lines. React recently made a change where they were exporting the prop types object from the React package itself, but they actually vendored it into a separate library. So a lot of people had to make this change where they had these import lines that included importing prop types from React, and they needed to just change them to import prop types from prop types. So this is one way that you might be able to do that. If your import declarations look like this in all of your files, you can call this find/sed command and do everything in one fell swoop, which saves a lot of time. The place where this breaks down, I'm going to talk about in a second, but if you're importing anything else than just prop types from React, which a lot of people are, you're generally going to want some more React functions than just that. If you're importing more than that, then your input string isn't going to look exactly like that. It's going to look something like, it's going to look slightly different. And so we need something a little bit more powerful. So in general, you want to have like a little bit of context around what you're replacing. And so that's what capture groups in regular expressions are for. Is anybody familiar with this concept? Yeah. Yes. So like I said, if we're importing React and prop types from React, we need something more powerful. This is showing up normally on my screen, but weird on there, so I'm sorry about that. This is an example of using a capture group with Vim syntax. We basically are saying the same sort of thing. We're looking at the current file. That's what the percentage sign means. And we're replacing every lowercase character wrapped in a capture group. That's what these parentheses are for. And they have to be escaped in Vim syntax. So that's why those backslashes are there. There's a little bit of noise. With whatever is captured in that capture group, that's /0 and an exclamation point. And what that'll do is it'll match every single lowercase character in your entire source file and add an exclamation point after it, which isn't very useful. But a situation where I actually did have to do this was in one of our PHP projects, we had a bunch of lines like this at the top, which are very unsafe references to classes. So each of those things lives in a file somewhere. So bologna, Limburger cheese, and liquid garbage are all going to live in some source file somewhere. And what we really wanted to do was replace those things with a direct reference. So that's what this does. This says like if it says find this class and then refer to its class name, and then it'll give us back that same string but in a safe way. So if we are trying to access a class that doesn't actually exist, this will throw an error. And that actually comes in handy quite a bit. So we had to make this refactor from that syntax to this. And it helped out, and it was great. And it only took like 2 seconds with regular expression replacement with capture groups. Is everybody following me? Am I going too fast? OK, cool. All right, so I'm going to take a quick break here and say that before we move on to the next bit, where I'm going to start talking about like domain-specific tools that you can use to do these large-scale refactors. I want to sort of plug IDEs for a second. So when I was working at Cellar Labs, we used PHP, and I swear to God I couldn't program PHP without a good editor, a good IDE. So I used PHP Storm here, and what that gives you is sort of like some context-sensitive way to modify your code safely. And I think this is particularly useful in languages that are, like by definition, kind of unsafe. So like we saw in the previous slide, PHP does like to do things like refer to code object things as strings. And so when you're doing stuff like that, you want some level of like safety when you change a whole bunch of code. And IDEs really give you that power better than most tooling does, because people are building things around the language, the frameworks in that language, and the common patterns in those languages. So being able to do things like find an occurrence of a specific function call and quickly change it, and having an IDE sort of handle that for you is a major benefit. And so this kind of extends to languages that don't have a good IDE as well. And basically what I'm saying is like use your tooling for your language. If you write Lisp, for example, you might have really, really good plugins with Emacs or something. But by and large, I've found the best way to safely like munge this code, delete a whole bunch of crap, and make sure that it's safe is by using an IDE. So if you've got one, I would recommend at least giving it a good try. I know a lot of people don't like them, and I use Vim myself, but only because I don't have an IDE for Haskell code. So.
Just use Atom.
Atom.
It's becoming more and more IDE, like you're intentionally adding compilation time.
Yeah. So the problem, I have a few problems with Atom, but
Great if you want to waste 2 gigs.
so that's one issue. The other thing is like whenever you have, I mean, it's sort of like comparing Atom and Vim or Emacs. Those are all kind of lumped into the same thing, in my opinion. You've got some like third-party plugins that will do this stuff for you, but it's nothing like a good IDE will, because a good IDE is built for a specific language, and typically, I mean, if you choose the right ones, it will do that stuff like very, very well. And I haven't found that level of tooling anywhere else. I think because it's a marketed product, an IDE like isn't going to make mistakes quite as often as like an open source extension to an editor will. Although there are really good ones.
Often does help. Not as much as an IDE, but it's nice when the
Yeah.
linter complains at you rather than a runtime error.
Yes. Yeah, definitely. Linters are great. Yeah, in general, just use the best tooling that you have for your language. Like I said, I don't have an IDE for Haskell. There isn't one. So I use a bunch of Vim plugins that are third party, and it works great. And I'm sure that there's a lot of that stuff for Atom as well.
So I know in Clojure, I mean, to me, there's like a benefit of having 2 editors. Emacs is very comfortable. I like working in it. But there's I forget what it's called now, but there is an IDE that's based on IntelliJ. You know,
Oh, yeah.
It's awesome for refactoring because it actually understands your code tree. So like you were showing the global string replace, well, with the IDE, because it understands, you can say, okay, I want to rename this object and all references to it. And other things that happen to have the same name aren't going to get changed because, you know, there's no route to it and it's not calling it.
Yeah, exactly.
I'm a total JetBrains fanboy. I have the toolbox, so I get everything and I use all of it. It's great. But I just wanted to comment. I feel like you should having an IDE can can also bring a lot of value organizationally, where like I don't think it's if you have someone start and on day one they open up the project that is your product and a big green button hits them in the face that says this is how you run the app, and then another green button that says this is how you run the tests. You can't undervalue how you can drive adoption of your team. You know, everybody will start doing things the same way, and you get that momentum.
Yeah, that's a good point. So most of my work has been in small startups, and so we've got a variety of people using a variety of different tools. But that is a really good point. Like for teams, if they can kind of converge on something, I think it definitely does help. Yeah, it's a good point. I've heard of that. It's not. I think Haskell's, so it's still a third-party plugin by somebody. I've tried like a number of things, and what I've settled on is just a Vim configuration, which works for me. If there were like some like Haskell IDE that was developed by, for example, JetBrains, I think it would probably be amazing. But yeah, we definitely lack that.
I'll tell if you would buy it.
Yes. Hey, there's like 10 of us on the team that I'm on now, so it's not quite so obscure. Okay. Any other questions before we move on? Cool. The first half of this talk was about string replacement, and the second half is too. So the next thing that I want to talk about is kind of stepping it up to the next level. All we're doing when we make refactoring changes is string replacement at a certain degree. So the first 3 slides were about doing these like small kind of string replacement things. And the rest of the talk is too, but I'm talking about doing it at like a higher level, I guess. So the first thing that I want to talk about is scripting your refactors. And what I mean by that is doing something ad hoc to your project in some script that you write. So take your program as input, output a new program as output. And this isn't something that I can just like show you a direct string replacement for. This is something that's going to happen kind of ad hoc. So when I showed that slide of the pull requests that I had where I was deleting like 10,000 lines of code, most of the time this is what I did. And I'm going to give you an example of the process that I took to handle one of those things. So this is an example process. So assume that you have a pretty big JavaScript project, and it's gone through a bunch of different hands, and it's gone through a bunch of different iterations, and maybe you're a startup and you're moving quickly, and you've pivoted a bunch of times. So you've got a bunch of code that you're pretty sure isn't used, but you're not totally sure. And so you're kind of afraid to get rid of anything because you don't know what it might touch. So I wrote this program and another one for PHP, and 2 of these things are what deleted like thousands and thousands of lines of code from our projects. And it wasn't very hard because it didn't have to be perfect. It was like one of those things where like I could run it, look at the output, and like kind of manually munch some stuff, and it worked. But anyway, all right. Backing up, the process was this. So we had a bunch of JavaScript modules in some directory somewhere. We iterated through all of them, and then look at like all of the imports that JavaScript module was doing for each one. So we might have been we were importing a bunch of different things from different parts of the application in each of our modules, and so we recorded that, and then we'd count how many times each JavaScript module is imported. So after we parse the imports, we just increment some counter for each import. And then if the count for any module was 0, we just, in my case, we just basically made a note. So just output like, hey, this thing is unused. It's not imported anywhere. But you could take the route of just deleting the file. I would encourage you, if you work on a project that's been through a bunch of hands and a bunch of iterations and stuff like this, to try this out. It's kind of a fun exercise from a programmer's perspective, I think, because you're dealing with code, and like code is what we live and breathe. It's fun to kind of like parse a source file and just like look for strings of imports and do this. And it will probably show you some stuff that's not used. This was something that my IDE could not give me. It was something that we didn't have a third-party tool to do. And it relied on a little bit of domain-specific language, or domain-specific information. So in this case, like I had to know where all of those JavaScript files were, and like the way that the imports were structured, because like it's not built into the language the way that imports work. So the imports were like string references to parts of my program, and so I had to know a little bit about this to write this script. But it was probably maybe a 50-line script. And I think running this yielded like a negative 2,000-line diff, which just removes a ton of noise from your code base. So that kind of stuff is great, and you should try it. Has anybody done something like this? Okay. Yeah.
On a much smaller scale today, one of the network engineers in the back was trying to write a script, and he had like this 26-line script, and I just deleted all but 4 lines, and it worked.
Nice.
I mean, it was a small, it was just funny guy.
Yeah. Yeah.
I had one project that was a little more complex. It was our company published a public API, and then we had all of our third-party integrators. We had all of their code. So it was a big, let's list all our public APIs. Let's see which APIs are being consumed, and then find out, which API calls we can get rid of.
Okay.
But that
Yeah.
it was in the Java world, so instead of string parsing, that was let's load the class, and then the JVM gives you the ability to say, let's look at this class, let's look at all the methods that it consumes programmatically instead of the string manipulation.
Awesome. Yeah. Sweet.
I once was in a situation using a really terrible system, and in order to try and make it a little less terrible, I did try to write a script that would identify all of the import relationships, but unfortunately, because it was terrible, it wasn't really possible. I've ranted about this particular thing before enough times.
Okay.
Those of you who've been here before and heard me know what I'm talking about.
So I had a nice one where my current job,
Oh.
where it does the refactoring or it does it's in Go, so it runs some of Go's tooling
Yeah.
to help with that stuff. There's like Go imports and Go format,
Uh-huh.
but it's kind of a large code base, so it's crappy to run that to do like a dump find on all the Go files.
Uh-huh.
So instead, I have it go through the git log on your branch, and then run git status, and then put that in a file and do a unique and a sort, and then say, oh, this file still exists because deletes don't count. Then run the tooling.
Oh, cool. That's awesome.
Yeah. So now you can say for what I have changed, what do I need to clean up?
Yeah.
What needs to be cleaned up?
So that's a really cool like integration with Git. Yeah.
Actually, I kind of had a question since we're talking about
Sure.
JavaScript, and it's honestly a place where it would be useful. Are there more generic tools for code walking for JavaScript?
I don't know.
You know of? Okay.
Yeah, I don't know.
Some languages really lend themselves to it a lot better than others.
Yeah. So, I mean, I should mention for Haskell, we do have something like this called Weeder, which will just detect any dead code, stuff that's not used. And the compiler also will like warn you about like variables that are unused and stuff like that. But yeah, I don't know about anything for JavaScript. That does not mean that anything doesn't exist. Yeah?
I think the only place where that would probably break is like if you had some
What do you mean?
So like some factories might work off like some string input that isn't going to necessarily happen until like runtime.
Sure. So that kind of plays into what I mean by like your ad hoc tooling doesn't have to be perfect. So when we wrote this script, it was run and like we had a couple of false positives for reasons like that, but for the most part, it like turned up a bunch of stuff that we knew that we didn't need. So you can be a little bit safe about this and still kind of see a bunch of benefits.
I wonder if there's tooling or languages where globals are used more, to where you can input a variable name and then it will check through your code and return you a list of functions to where it writes to the global and to where it just reads to the global.
Yeah, I don't know.
You know when you have a weird bug, you know what's doing spooky action at a distance.
Yeah. Yeah, I mean like that's
Be really good.
yeah. That seems like something that you could do this for. That kind of thing. But, you know, yeah. I don't know. Super useful. It's a really useful technique. And for a lot of different languages and environments, you'll probably find third-party tooling that does this kind of thing. But when you don't, just know that it's not that hard to write a script that will approximate it for your own specific purposes. Because a lot of third-party tooling is built around this idea that it has to work for everything. So if it doesn't have to work for everything and it just has to work for your code base, it's likely to be a lot simpler.
Sometimes it only needs to run your machine.
Yeah, exactly. All right, cool. Is everybody like comfortable with this idea? Cool.
You do have to be careful, as I've often said, the only thing that lasts forever in computer science is a one-off script.
Yeah, don't share it with anybody. Just do it on your own. Just publish negative 10,000 line diffs and like throw away the script. All right, cool. So now I'm going to move on to the thing that I really wanted to talk about, which is this. I'm using compiler as like a very loose definition. And what I mean is like when you compile code, what you're doing is taking some source code and turning it into other source code for a different, for something else. And it doesn't necessarily have to be for something else. So I'm talking about taking code, converting it into an abstract syntax tree, so actually parsing that code, and seeing what it looks like as like an actual formatted thing, and then producing some other code. Does anybody, just as a brief kind of overview, like an abstract syntax tree is just going to be like a valid code representation of your code. So you'll have some data structure that represents the code that you've written, and you can kind of manipulate that in a different way. It's a really cool concept. I think it's like kind of like catching on now in the JavaScript world, which is sort of interesting to me, because people are writing Babel plugins that take their like ES6 and turn it into something else. But essentially what a compiler is like a code rewriter that has pretty deep knowledge of the input. And so that's kind of what I want to talk about today, a process that I just recently did on some Haskell code at work that is in the same vein of like ad hoc tooling, but really helped us accomplish a goal of like cleaning up code. And so for this domain, what we were dealing with was arbitrary test data generation. So the idea here is that we want to be able to pull our database entities out of nowhere and when we're testing and like do some setup on the database entities and run some code that uses those things and like assert that something happened. So for example, we might be writing an API endpoint that returns all of the students in a course. And when we do that, we need to have all 4 of these things. So a teacher is required for a student to exist. A teacher is required for a course to exist, because somebody needs to be teaching that course. And a course membership is a correlation between the student and the course. So if we're saying we want to get all of the students in a particular course, we need to have all 4 of those things. Is this comfortable for everybody? Yeah.
I don't see how a teacher would have a student dependency, or you don't need the.
In our case, we do. I mean,
Okay.
it's just a domain choice. Yeah. So yeah, but that is valid. Yeah. I mean, it's not obvious why that is, but
Sure.
it just take that as a fact. But yeah.
Cool.
In most of the programs or in most of the applications that I've been a part of writing, we have some concept of like, I want to create a thing and just give me a random one. And then I have these dependent things that I want to create, just give me those. Given that I have the thing that it's dependent on. And so that's the domain that we're working in. We basically want this big graph here of dependent database entities, and we want to build them in our test files. Okay, so this is what we had a lot of this in our code base, and we have since stopped using it. So we moved on to a different library to do this stuff. Basically, what this says is this is a type definition that basically says that like I have a graph of things that relates all this stuff together, and it's encoded in the type, which I'm seeing a lot of eyes glaze over. Like it's too complicated for what we're dealing with. This is really, really cool, but if you take a look at the code, you're going to be like, what the hell am I looking at? Like if you don't know Haskell at a very high level, you're not going to understand this. And on top of that, we're kind of coupling all of this graph data together, when really what we want is to be able to just say, like, give me a teacher, give me a course, give me a student, and so on and so forth, line by line. And so for a bunch of different reasons, we kind of wanted to move away from this. And you don't really have to understand this, but you just have to like see it, because that's what we're going to be converting from. So what we're converting to was something like that looks like this. And what this says is like, I mean, you can kind of read this line by line. You say you want a teacher. The teacher doesn't depend on anything. So I'm saying, give me a graph node with the dependencies of nothing. It's just an empty tuple. So it doesn't depend on anything, and it is a teacher. We're giving a little bit of an annotation there that just says like, this is this thing that I'm building as a teacher for clarity. And so on and so forth. So a course requires that we have a teacher, so we're passing that in as dependencies, and so on and so forth. We also have these declarations of the dependencies. So this right here is just saying that a course membership depends on a student and a course. So if I want to create a course membership, I need to give it the student and the course that it's relating. That's all this is saying. And you guys don't need to really understand exactly all of this, but it's useful to kind of see like this next to the other thing that we were trying to move from and to. Does anybody have any questions about this before we move on? I know it's Haskell code, so it's got a weird syntax.
So you're saying we should write compilers to Kovach code?
I don't know, I did. I mean, by my loose definition of compiler, yeah.
Is the last line supposed to be at student?
No. Yeah, good call. That should be course membership. That is confusing. Yeah, so the membership there should be, that at should be course membership. Yeah.
Course membership? So, but there's no course membership defined elsewhere here, right?
Right, so
Just be at membership?
course membership is the type of thing. So this is the type.
Oh, I see it down there. Okay, yeah, sorry.
Yeah, no problem.
I kind of have an idea that's not quite formed before I get on.
Yeah, sure.
Haskell implementation of mini-conrun?
Sorry,
Do you know of a Haskell implementation of mini-conrun?
I do not.
I don't know if that's really relevant or not. It's not quite gelling in my mind. But for some reason, I'm looking at this as seeing a logical, a relational thing other than types.
Yeah, so this is definitely a relational problem. We want to create a bunch of entities and relate them together. And so first we created a teacher, then a course, then a student, and then a membership, a course membership. And we're relating them all together using that final argument.
I'm not quite putting it together, but I kind of had an idea. Go on.
Okay, that's okay. Yeah. Okay, so there it goes. The program that I wanted to write was something like this. Something that would take that H-graph representation of the stuff and convert it to this representation in the new library.
But you did it manually, right?
I did it manually for a minute.
Well, no, I'm just because it
Oh, yeah. God damn it.
If you used your compiler,
It would have fixed it. Exactly. Exactly.
Does the order matter on the bottom? The second in the new representation? Is
Yes.
the order important?
Yeah. Actually, yeah, I should have mentioned that in the last slide, but that is the reason we had to write a compiler to do this. And I wasn't able to do like a string replacement type thing. Because the dependencies type is ordered, this is an ordered tuple, so I couldn't write I couldn't give it, like in this line here, I couldn't give it entity key course and entity key student. It has to be in that order.
Did student and course both have to be defined before you did membership?
Yes, yeah. So these are referring to those variables. Maybe I'll spend a second and explain the syntax so that everybody's not totally lost. So, all right, so we've got some Haskell code. The first line says call node with @teacher with no dependencies. And that left arrow there just means bind it to a variable. So teacher is a variable now. That's like an arbitrary teacher. And then the second line says build a course using the entity key for teacher. And what that means is like the ID. So we're giving it like the database ID for that teacher. And we're building a course with it. And so we bind that to the value, the variable name course, and so on and so forth. And yeah, every time we refer to one of the dependent things, we have to have those variables in scope. Are we following now? Okay. Yeah, okay. And so that brings us here. I've got this H-graph representation, and I want to convert it to this. But we need the ordering. We need to preserve the ordering, and that's really important. So I'm going to walk through what I did in order to make this happen. At the top, we've got that H-graph, and at the bottom, we've got the sequence of commands that we want to run. Some things that I would like to point out. With the H-graph representation, we have basically, like if you look at the top and you look at the bottom, you'll notice that like the variables are flipped around, like flipped upside down, like teacher comes last in the top, teacher comes first on the bottom, and course comes right after that. That's because the way that H-graph wants to order that stuff is from basically the opposite perspective of how you'd order it in like code where you refer to the entities themselves. So it wants like at the top it'll say like it'll give you the thing that like how do I
Root node?
yeah basically. So like the root node is going to be the root node will be at the top, and the leaves are going to be at the bottom. Anything that's dependent on anything, so like student and course are dependent on teacher. Teacher has to come after those things. Course membership is dependent on student and course. Student and course has to come after that. And that's how the library was built. But when you talk about it in code, you need to do it the opposite way. But you can kind of see this correspondence between those two things if you like flip it upside down in your mind. And so I wrote this program called convert hgraph, and what it does is it'll go from the bottom up there after parsing that code, and it'll just go from the bottom up and convert it each line into one of these things. Okay. So at the bottom of that hgraph representation, we have teacher. So we want to build a teacher, but I want to convert it to that second line there that uses the new library. So the first thing that we notice is that like teacher can just be, we can just name that thing teacher, which was the name in the graph in the first place. The next thing that we need to do is like pull that type down. So when we talk about doing this is called graphula, and I'm going to call it that. This is graphula. That's hgraph. So I keep like stumbling over this, like this is code, but that's graphula. And in graphula, we need to use that type variable from there and just pop it in. So that's no problem. And then the dependencies of teacher is just nothing, so we can just throw that in there. And this is like a very, very easy way to, like this case is super easy. We can write that Haskell code, no problem. And crucially, at the end of this, we need to record the type of teacher. Because as we keep going through that graph and producing this thing, we need to know the types of each of the values that we've produced beforehand. So we record it. We record that teacher is a teacher. Okay. So that was like a really simple tuple reordering. This one is a little bit more complicated because we actually have dependencies now. So at the beginning, the variable name that we have, again, we're just going to do this thing on the left where we take the name of the variable that we're trying to produce, copy the name down. But in this case, we actually depend on teacher. So we have to say well, that has to go in the dependencies of student somewhere. And the ordering is very easy in this case because we only have one thing that we're dependent on, which is the teacher. So we look at it and notice that it's just an only teacher ID, so we just cram that in there. But if we didn't know at this point that teacher had type teacher, then we wouldn't be able to do this safely because we'd be putting a value in there that we aren't sure of the type of. And that ends up having some pretty disastrous effects. So we definitely have to store the types of things.
And because you're doing it programmatically, you can count on the fact that a teacher type is going to have a teacher ID attribute, and it's going to be capitalized that way.
Yeah. So that's all kind of like domain-specific stuff. But a teacher ID is what we need here, and we know that teacher is the thing that kind of carries that, so we can use it. Yeah, and there's some other machinery around like inserting that only there because we know that this is an only teacher ID, which we can also infer from the dependencies declaration. With course, we're going to do something similar. Just bind the name, do exactly the same thing, and then pop that course in there. And then for a membership, we have to actually order some stuff around. And so what happens is we're going to do the same kind of thing with the naming, use the same thing with the types. But when we order, we have to look up, like, we've got student and course, these two things in the top tuple. Dang, you guys can't see that. The dependencies in the href type there, we actually know the types of those things from here. And we also know the dependencies of course membership, so we can order them appropriately. So I can look up the type of student, I can look up the type of course, and then I can look at the dependencies of course membership and decide like which one of those things goes where. Does that make sense? Kind of.
Are you still doing string matching on student ID?
Yes. Yeah. On student ID, yeah. Because we're just recording like this and like popping ID on the end of it.
Okay.
So there's a little bit of that. But we've got like, the program is like, it's parsing the top part and determining how to turn it into the middle part.
Because you've pre-authored the bottom line.
Yeah.
Okay.
Yeah. So that like lives in our code base, and it's the declarations of like what depends on what. But yeah, that's it. The reason that this thing was necessary was essentially for that ordering. I ran into this issue where I decided like I'll not do that and just go with like a string replacement kind of thing, trying to convert that to that. And what ended up happening was like I didn't know what the types of things were that were supposed to go in each of these little tuple spots. And I ended up with like a whole bunch of type errors. And doing everything like line by line also, if you recall, like the href definition is like backwards. So I couldn't just like replace all of the lines. I'd have to replace all of them and then reverse them and then hope that the types matched up, which is not going to work. And so what ended up happening was like I spent a few hours writing this thing that actually like looked at the Haskell code, parsed out all of that information, and then like kept these dictionaries on hand in order to populate this stuff with like data that I knew was going to be typed correctly. And all of a sudden, like I had something that actually worked, and didn't require very much overhead on my part. So here is the final product. So I spent a few days doing this, and the final pull request is there. So I ended up removing 2,200 lines of code, or 2,400 lines of code, and adding 2,200. So this was like extremely efficient. I mean, you can see a demo of it down here. If I were to do this by hand, it would have taken forever, just because, number one, it was extremely error prone. I tried doing this by hand, and it was impossible not to make a mistake because I kept having to refer back to the dependencies types of each thing, figure out the type errors, order everything properly, and somehow type every single one of those little type applications there correctly. And it just ended up being totally unmaintainable. but this was something that we definitely wanted to get rid of. So yeah, like writing this tool definitely like paid dividends. Whenever I go to write a test, I don't have to deal with anything like this anymore. I can just deal with actual code, which is great. Yeah. Any questions? I think that's all I have.
Can we look at the code of for your compiler that you wrote, or is that too close source for us to see?
It's closed source right now. We could reasonably open source it, and there should be a blog post at some point about it. But yeah, the reason right now it's closed source is because those dependencies declarations that I was talking about, they're just like hard-coded as a string in that program right now, because it was, like I said, like it was an ad hoc thing that I did for work. And yeah, I mean, it's not a huge change, but eventually we may open source it. It's not very useful for anyone but us, because hgraph was an internal library that somebody wrote that was open sourced, but like it's super high level Haskell, and I think only the person who wrote it and like a few other people know how to use it. And then Graphula is even newer, and it's something that we're trying to get off the ground. I think it's great, but we haven't like evangelized it very much yet, and there aren't very many people using it. So like the amount of people that would actually benefit from this exact program is like almost none, like us basically. So we haven't bothered open sourcing it just for that reason. But yeah, I mean, eventually there should be a blog post about it at least. And hopefully we can open source it. We just have to find the time.
Just
Yes.
to mention that it's not really relevant to any of it, I don't think, maybe. I don't think it's really relevant, but to answer my earlier question, apparently there's several implementations of Miniconrad for Haskell.
Okay.
Can't really tell how mature any one of them is, though.
Cool. I'll have to check it out.
Something to mention.
Yeah. So I think that like, yeah, this program is very specific to what I was doing. But if any, I think like the takeaway here is that if you find yourself in a situation where you need your code in a richer format than just plain text to make some conversion, doing this kind of thing where you parse out the code, look at it specifically, and like kind of build up a new source code block from that. Like, I don't think that it's impossible, because I wrote this thing in a couple of days. It's pretty cool. So with Haskell, we have like a library that will parse the code. It'll parse Haskell code, and that's what I used. There are no doubt the same types of libraries for other programming languages, whichever one you want to use. And yeah, like, try it if you find yourself in that kind of situation. Yeah?
A good thing to do with the simple string replacements that you're doing in shell commands is to alias them to like a command called replace.
Yeah, yeah.
Save a lot of time and stuff.
Yeah, definitely. Like, you can go pretty deep into that with like Vim or whatever editor you're using. But yeah, definitely. I mean, I'm always in favor of like, if you use something all the time, like just alias it. Yeah.
Just curious, does Haskell let you write AST as well?
I'm not sure what that means. So like,
I've done this in the .NET environment where you can both look at, you can have some code and it could be compiled to an AST, and you can look at it to say, oh, like here's an if statement, and then there's things I do inside the if statement.
like,
But you can also construct, saying like, I want to build an if statement and I want to compare this variable to this constant value,
yeah, yeah.
and then execute them. Like, you could build an interpreter instead of a compiler.
Yeah, so we've got template Haskell, which will do essentially that. It'll let you like introspect different pieces of your program and like determine what to do based off of that, or build code at runtime. which I think is what you're saying. Yeah, like kind of working with code at a higher level. Yeah, we have template Haskell and we have generics, which will both do things in that vein. And I know that's along the lines of like macros and Lisp.
Okay.
Yeah. All right, cool. Thank you guys for coming out on such a rainy day.